Trigonometric equation. Basically, a trigonometric equation is an equation as one trigonometric function of an angle equals a constant, and we want to find the possible values for the angle. A trigonometric equation can be written as follows. Unfortunately, no rules exist that will always lead to a solution. The procedure to solve trigonometric equations usually involves both the reference angles and the trigonometric identities. In what follows, it is assumed that you have a good grasp of the trigonometric ratio values in the first quadrant, how the unit circle works, the relationship between radians and degrees, and what the various trigonometric functions curves look like, at least on the first period between 0 and 2 pi radians. If you are not sure of yourself, go back and review those topics first. Thanks for watching this video and don't forget to like, subscribe to the channel and activate notifications. It is very important to the continuity of this channel. Let's start with a very simple equation. The equation sine of theta equals 1/2 means find all the angles whose sine is 1/2. Let's remind ourselves of what the sine graph looks like so that we can see how many solutions we should be expecting. We see that there are infinite solutions to this equation, but trigonometric equations are usually solved for values of the variable between 0 and 360 degrees, or 0 and 2 pi radians. The solutions of trigonometric equations for which the angle theta is between 0 and 2 pi radians are called principal solutions. In this video, we will be concerned with finding the solution to such equations for which the angles are between 0 and 2 pi radians. Solutions of trigonometric equations may be found by examining the sign of the trigonometric value and determining the proper quadrant for that value. The sine function is positive in the first and second quadrants. We draw the unit circle to illustrate the quadrants. A sine value of 1/2 is a reference angle of 30 degrees, or pi divided by 6 in the first quadrant. We have already found the first solution, which is the acute angle from the first quadrant. So to find the second solution, we need to use the rule in the second quadrant. We will always write our solutions in radians. We can see there are two angles for which sine of theta is 1/2, pi divided by 6 and 5 pi divided by 6. Solve the following equations for the interval. First, rearrange the equation. Just as with linear equations, we will first isolate the variable containing term. The cosine function is negative in the second and third quadrants. We draw the unit circle to illustrate the quadrants. We need to find the reference angle to use with the rules in these quadrants. The reference angle is the acute angle from the first quadrant, and in the first quadrant, the trigonometric functions are positive. Therefore, when calculating the acute angle, we ignore the negative. Cosine of theta equal to 1/2 gives us a reference angle 60 degrees, or pi divided by 3. So, to find the solutions, we consider the reference angle of pi divided by 3 and we use the appropriate rule in the second and the third quadrants. There are two angles for which cosine of theta is minus 1/2. 2 pi divided by 3 and 4 pi divided by 3. To solve this equation, we subtract tangent of theta from both sides. Then we divide both sides by 6. The tangent function is negative in the second and fourth quadrants. We draw the unit circle to illustrate the quadrants. We ignore the negative to find the reference angle. The tangent of theta equal to the square root of 3 divided by 3 gives us a reference angle 30 degrees, or pi divided by 6. To find the solutions, we use the appropriate rule in the second and fourth quadrants. There are two angles for which tangent of theta is minus the square root of 3 divided by 3. The angles are 5 pi divided by 6 and 11 pi divided by 6. The left-hand side of this equation factors, so we will start with factoring. We now solve each of the factors, thus created two trigonometric equations. From the first equation, we get the cosine of theta equals 0. From the second equation, we get the sine of theta equals 1/2. We draw the unit circle. The cosine of theta is 0 when theta is pi divided by 2, or theta is 3 pi divided by 2. The second equation has already been solved. First, rearrange the equation. We will isolate the variable containing term. This equation involves the square root of 2. Sine of theta equal to plus or minus the square root of 2 divided by 2. We draw the unit circle to illustrate the quadrants. The reference angle is pi divided by 4 or 45 degrees. In this equation, we use the appropriate rule in all four quadrants. Pay attention.